rate of change. When you hear the words rate of change, I want you to think of slope. And if you remember slope from last year, we used slope as m, which is delta y over delta x, which is the change in your y's over the change in your x's. And what you'll be looking at are the average rate of change over a function. So if you hear rate of change, think slope every single time. And it'll make this much easier for you because you're looking at the changes as it's going over an interval. You're going to talk about increasing and decreasing functions. Increasing functions usually go up like this. Decreasing functions go down like that. And we're going to talk about the rate of change in function notation. So I've got these three towns here. I have town P, Q, and S. And if you'll notice, it starts in 1980, and every year, which is very consistent, all the way to 1985, I have the town populations. So if you were to look at it, they all start at 10,000s, because this is all in thousands. I said, oh, okay, this town is in 10,000. And then they do all these changes, and they all end up at 30. But what's different is how they change. So we want to determine the average rate of change for each function over the interval. And if you look at it, it's a change in the population over the change in time. Because if you look at this, we have, this is our time, and these are the populations of each of the towns. So again, we have like points here, where time is the independent variable, and then you're going to have town P. And then you're going to have time, and you're going to have town Q, and time, and town S. So there you have your like three sets of points. And the other thing I want you to recall, if you have the change in population over the change in time, if the populations of P, Q, S are my y's, isn't this the same as saying delta y over delta x? Because our time is in the x part of our points, and the population is in our y. So it's a bunch of looking at slopes for each one. Now, when you do these, let's go to the next slide. It's the same thing. I'm going to show you something I call carrots. I don't know why I call them carrots, I just do. But it helps you to see the rate of change. So the first thing is, here's a carrot. I go up 1 year, up 1 year, up 1 year, up 1 year, up 1 year. So this is constant, all right? That's my x's, or my time, all right? Now here's my towns. I have P, Q, and S. Now let's do P first. So I'm just going to do a caret in here. If I did this, I'd see this has gone up 4, gone up 4, gone up 4. See how this is really consistent? So you can say, oh, this went up 4,000 people per year. And this is what I want you to see. Because this town P are my y's, you're really doing slope is delta y over delta x, or if you will, you're doing delta p over delta t. So I look at the delta p, or the change, I'm getting 4,000 per year. So notice this is thousands of people for every 1 year. And if you see that line, it means the word per, or every year, 4,000 people every year. So this is a constant rate of change because every year it's going up 4 people. 4,000 people. Now let's look at town Q. Town Q looks like this. Well, if I were to look at each one individually, this went up 7, this went up, if you look at this one, 17 to 23, so that goes up 5. This went up 4, went up 2, went up 1. See how it's changing? So if you were to look at each one of these, it went up 7,000 of people per year. Then it went 5,000 people per year and 4,000. So if you look at it, it's still increasing, but at a decreasing rate. Okay? Now, if I were to look from here to here, though, you would notice they all increase the same amount of people, but it's just how they did it. So I can say, all right, this went up 17, excuse me, from 10 to 17, so it's 7 over 1, so it went 7,000 per year. Then went up, excuse me, that's 6, isn't it? Then it went up 6,000 people per year. Then it went up 4,000 people per year. Then it went up 2,000 people per year and then 1,000 people per year until it got all the way up to 30. All right, so these are my slopes, but my rates of change. So it's like it was really high and then it's decreasing. Okay? Town S, if we looked at this one, went up 2, went up 3, went up 4, went up 5, went up 6. So this one, the rates of change went from 2,000 people per year to 3,000 to 4,000 to 5,000 to 6,000, so I'd still end up at 30. So here I increased the population at a decreasing rate. It's still increasing, but it's slowing down. This one I increased my population at an increasing rate because it still went up, but it went up faster and faster. That's what I observed. But over the course of the time, they all ended up at 30. So if I was going to look at my average rate of change for the whole thing, I'd say, oh, okay, I have 30 minus 10, that's what I started with, that's my population for all of them, divided by the time, which is 1985 through 1980. So I have 20 over 5, okay, or 4. So the average rate of change was 4,000 people per year. But because they're all different, it's just interesting to see that they all end up in the same place, but they got their different ways. Right, now let's look at the average rate of change. So this kind of goes through this. The average rate of change, or rate of change, is a change over an interval, and usually it's over time. Again, think slope, delta y over delta x, because that will help you with this a lot, to think slope. And these are some observations that we looked at it. So we saw that Town P's population is actually growing at a rate of 4,000 people per year. Town Q's was changing. Again, the rate of change was decreasing even though the function was increasing. And again, Town S is changing. The rate of change is increasing. So it kind of just shows you how rate of change does make a difference. Now here it says if you were going to plot these three towns on a graph, what do you think they would look like? So I'm going to just do a quick sketch. So again, I have this is time down here. So we're going to start here, 1980, put here, and then we're going to go all the way to 1985. And we're going to go 10, 20, 30, oh, that's a little bit close. 30,000 people. So this is a population in thousands. Okay, now they all, I can start them all here at 10,000, and they're all going to end up here at 30,000, every single one. Okay, now if I were to do 4,000 per year, that would give me a straight line, and this would be which town? Well, Town P actually had a rate of change that was constant, so it makes a line. Okay, Town Q started increasing kind of fast at first, and then it started decreasing a little bit over time, so it still ends up there, but it kind of looks like this. And here, the last one, so this right here was Town Q. Town S started at 10, and it grew slower, but then it speeded up and still ended here. So this is just a rough estimate where you can see these two are not lines because their rates of change have changed. This one was a constant rate of change of 4,000 per year, so it made a straight line. So again, I'm going through, what do you notice? All three curves pass through those points, and hence they have the same average rate of change over the entire interval. However, any sub-interval of 3 years, the average rate of change is different. It's important to make the connection between speeding up and slowing down with the rate of change. Right. Increasing and decreasing functions. If Q equals f of t, again the point TQ, get used to doing that. If f is an increasing function, is the values of f increase as t increases. The average rate of change is positive in every interval. F is decreasing if the average rates of change decrease as t increases, or the average rate of change is negative on every interval. Let's look at this graphically. So I have this function here. If I were going to look at increasing and decreasing intervals, okay, what you want to look at is this is the increasing part, but then right here it kind of changes and then it decreases to about here, then it increases. So you can actually say, well, what are my increasing intervals? Well, this is -1, -2, -3, -4, so we'll use -4 here. It looks like it's decreasing from -4 all the way up to -1. And so how we would say that is it's increasing on the interval -4 to -1. And we usually use parentheses because you don't want to include the spot right here, because is this increasing or decreasing? It's neither. And then it looks like it's increasing again here about, I'd say, it looks like 1, 2, 3, 4, about 4 again. This is a 4. And it's increasing to here to about, looks like 5, 6, 7. Looks like to 7. So, and it's increasing about from 4, the interval 4 to 7. Now remember, I'm using parentheses here for intervals. They're not points, but this is an interval, as opposed to using a bracket. The decreasing part is the part in between. It's this part from here to here. So I can say it's decreasing from -1 to 4, because that's where it's decreasing on that interval. Right? Now let's actually figure out how to find if something is increasing and decreasing. And again, I'm showing you this notation because it kind of throws people off. But if I'm looking for the change in Q over the change in time, I'm going to take two different points. And when I say f of b minus f of a, you're looking at the change in your y's again, all over the change in your x's. But you'll notice this notation here shows you, if I had these points, the point A, f of a, okay, that's a point, and the point B, f of b, if I were going to do the slope here, I'd say, all right, I'm going to subtract these two, because slope is delta y over delta x, so I'm going to subtract them. You can go this way if you want. So I got f of b minus f of a all over b minus a. That's where that comes from. But it's the same thing as doing delta y over delta x. Alright, so I have this graph here, and this graph is a parabola, and here it's x squared minus 2x plus 1, so it's an opens upwards, and we want to know the rate of change between 0 and 2. So here I have x is 0, something, and then 2 something. So the first thing I want you to do is find what the something is and look for this. So here's the point 0, and here's 0, 1, so the point 0, 1, and I want to look between 2. So here's 1, 2, and it's 2, 1. So when I'm looking for, here's this point here, if you can see it, I'm looking for the rate of change between those two. So let's draw a line, and it looks like it's a straight line right there. Now I want to look for the average rate of change. Well, the average rate of change, this is an A, the average rate of change, which is slope, by the way, I keep telling you that, is going to be the change in f of x over the change in x, or delta y over delta x. So I'm going to just do slope. So slope is delta y over delta x, and right here I'm going to do 1 minus 1, there's my change in my y's, over 0 minus 2. And when I get that, I get 0 over 2, or 0. So the slope is 0. Alright, the slope is 0. And that makes sense because, look, it's a straight line. Isn't the slope of that line 0? So that's my average rate of change. It's 0 because they kind of cancel each other out, and it's a flat line. Alright, let's look at this next one. Same graph. Now they want us to find the average rate of change between 2 and 5. So I have 2 something and 5 something. So here's 1, 2. It's like the point 2, 1 again. And then 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like 15, 16. Okay? So right here and right here, I don't know if you can see that, I want to look for the average rate of change. So it's 5, 16. So I know the average rate of change is slope. So I'm just going to do the slope between the two. Now, by looking at, if I connected a line between those two, sorry, it's not very straight, but you'll notice that that is a positive slope. It's pretty steep too. So let's try it. Delta y over delta x. So I'm going to subtract. So I got 1 minus 16 over 2 minus 5. Okay. And what I get over that is negative 15 over negative 3, or I get a slope of 5. And that makes sense because it's pretty steep, and the bigger the number, the more of a slope. So the slope of that is 5. And for the last one I want to show you, I want to find the rate of change between negative 3 and 1. So here's 0, here's negative 3 right here. And I want to find between 0 and 1. So the point here is negative 316, because it's way up here. If you can see it. And I want to find the next one is going to be 1, 0. Oops, sorry, 1's over. I'm over too many. 1, 0's right here. So then if I were to, oops, sorry. If I actually was to draw the line there, I'm looking for that average rate of change. It looks like it's a negative slope. Let's try it. Slope is 16 minus 0 over negative 3 minus 1, or 16 over negative 4, or negative 4. And that looks like a negative 4 slope. That's the basics of rate of change.